Year 12. This tutorial, I'd like to go over the solutions for the 2023 Independent Trial HSC. So I will start with the multiple choice questions. Question 1, steel machine component containing 0.55% carbon requires surface hardening. Which of the following processes would be most appropriate? 0.55 means that it's got sufficient carbon to provide a case harden, and you don't have to add carbon to it as you would with steels below 0.3%, and so you can't use carburizing, or you don't have to, because it's got sufficient carbon there. And the answer obviously is induction hardening, where you just supply heat and rapid cooling to the case, and it provides a soft, ductile core. Number 2, which statement best describes the coefficient of friction? It's the coefficient of friction generally is a number between 0 and 1. It's a ratio, but when you have sticky tires, as you have with slicks and drag racing tires, you can have a coefficient of friction up towards 2. So it is the ratio between the force of friction and the normal force between the two surfaces. So it's important that it's a ratio. So it's D. 5 pre-stressing tendons that have been post-tension are shown. So here's the post-tensioning tendons. You've seen this. I've shown you this particular diagram before, and you can see the wedges, the collets that hold the tendons in place after they've been stretched. And these tendons have white paint on them, so when they're in the untensioned state, they just spray white paint, and then they apply the jack to it, and then they use this plea formula to pull it out so you get the desired force on each one. So each tendon is 15 millimeters diameter, and it's got that load, has to have that load on that the engineer has determined for each of the tendons. And the tendons have a Young's modulus of 200 gigapascals, and they're 30 meters long. When you see 200 Young's modulus given, you almost certainly have to use the plea formula. So here's the plea formula. Make sure you put down all of the data here, because in a extended response question, the examiner can check all of this if you get this answer wrong. But obviously, with multiple choice, you either get it or you don't. But this is the correct way of doing a extended response question, by putting all the data down here. Make sure you put the values out here, because if the question's worth, say, 4 marks, the last statement for 1 mark will be demonstrate some knowledge of the question. And if you've put all this here, you've demonstrated knowledge of the question, and you'll get 1 mark. It's worth 4. This is only worth 1, so you either get it or you don't. And so you put the load in. Make sure you can't put kilonewtons in an equation unless you really know what you're doing. So you have to put the full value in. Use standard notation. 30 meters long, there's Young's modulus there. And I generally make sure that I show the examiner what formula I'm using, and then substitute here and get your answer here. So you're only putting a small value here. You're not putting all this in over here. And it works out to be 200 millimeters. So A is the correct answer there. Which statement best describes a uniformly distributed load on structural members? A UDL is a load that is evenly distributed, like they might be taking the mass or the load of the concrete beam into consideration for the calculation. Now, you only have to know about UDLs. You don't have to do any calculations on it. So A is the correct one. The load is evenly distributed over the structural members. There's no point loads, there's no load plots in it. So it's the load that's evenly distributed over the structural members, which is the correct value on the strain axis to determine proof stress on a stress strain diagram. You should know that straight away. It's 0.2% strain. I think most people got that. What are three things that inhibit dislocation movement during the deformation in metals? And alloys provide stranger atoms. B is the correct answer here. Grain boundaries and other dislocations. They're the three things that inhibit the movement of dislocations. In other words, it strengthens the metal. The car parked on a sloping surface, the coefficient of friction between the tyres on the surface 0.3. These are easy questions, so make sure that you know how to do this. What's the maximum value of part 5? Before the car tyres begin to slide down the slope, you know that this is the angle of static friction, and that equals tan phi equals mu, which is 0.3, and inverse tan, and you get 16.7 degrees. So D is the correct answer there. The Phi 10 cable is a strength of 1018.6 megapascals. When you're given a value as accurate as that, you know that the answer is going to drop out fairly evenly like this without any decimal points. So that'll be a giveaway if you get the right answer. Is to be used, like you can predict it here because you've got these answers, but if it's in a extended response question, that's a good way of figuring out if your answer is an even number. It's almost certain you've got the right answer, hopefully. To be used to lift machines in a workshop, the design engineer specified a factor of safety of 2. What's the maximum allowable mass? We're looking at mass the cable can support. So you put the formula down here that you get in the formula sheet, and you were after load that will convert to mass later. And so the load is equal to stress times area. Data here. Make sure that you show the formula for area, substitute here. And I haven't put 10 to the 6, 10 to the minus 6 in here because they cancel. And so you get this value here, which is 8 kilonewtons, 80 times 10 cubed newtons, which is 80 kilonewtons. And the factor of safety is the maximum load over the working load. We're after the working load, so you just divide 80 times 10 cubed by 2, and you get 40 kilonewtons. You halve that, so that would be 4,000 kilograms. And obviously C is the answer there. Which is the correct statement regarding true length lines in orthogonal view? The line is true length if the line projects as a point in the other view. That was well answered. Which is the most likely to occur when a number of cross links is increased in an elastomeric polymer? I remember when you get maximum cross-linking in an elastomer, you get ebonite, which is just a hard rubber. And so increasing the number of cross links will stiffen the polymer. And that's what vulcanization is. In car and truck tires, they stiffen the polymer so that the flexibility will still be there, but it will have good wear resistance. Which of the graphs shown represent a digital signal for a control circuit? Now, a digital signal, obviously, is the transmission of bits, and which is on and off, and you have to go, this is an analog graph, so that's not it, and this is the correct answer because you've got off here, on, These are incorrect because you've got a variable amplitude here. So B is the correct answer there. What's the main effect of an excessive angle of attack on an aircraft? Excessive angle of attack creates turbulence and it reduces lift on a wing. And so it's a loss of lift. The first stage in precipitation hardening or artificial aging process is to heat the metal to a temperature below its melting point. What's the purpose of this stage? The only materials that can be precipitation hardened are those that will, on heating, produce a single phase. Which is a uniform structure when you have a single phase. And so A is the correct answer there. Here's a cantilever beam. It wasn't answered very well. You had to replace these two forces with a force couple system at A. And so some of the vertical forces is equal. If you say up is positive, you've got -5 down, and so you've got a force of 5 kilonewtons acting down, so it's a shear force. And the rotation force is take moments about A, and you'll get the rotation of 5 kilonewton meters anti-clockwise. So C is the answer. The sheet aluminium alloy of an aircraft's fuselage requires joining by riveting. Which will be the most appropriate rivet material? Now, if you can get a rivet that is close to the material that you're riveting, that is ideal. You don't want materials that the rivet's made from that are quite a distance from that sheet material on the electrochemical series. And so aluminium alloy is the choice here. These other three materials would be further away from aluminium alloy on the electrochemical series, and so you'll get a cell, and it will cause corrosion. So aluminium alloy is the correct selection there indeed. Question 16, this electrical circuit has 3 resistors in parallel, and you've got a 36-volt battery here, and it's a 66 amp hour battery, so it'll only provide 66 amps per hour. So how long will the current flow in the circuit? So you've got to work out the total resistance, make sure that you say it's 1/R. Just don't say that it's R equals 1/6, 1/4, 1/2. It's 1/R because you have to invert the final answer, and which is 1.09 ohms. And then you've got to work out the amperage at 36 volts, and with a resistance of 1.09, set it out like this. And so you get 33 amps, and the time is the amp hour divided by the amps, so it'll give you hours. And so you've got 66 over 33, and you get 2 hours, which is D. This is an aircraft propulsion system, which best describes this aircraft propulsion system. And so you can see that this is a turbo fan jet engine with 80% of the thrust coming out between the actual gas turbine and the shell on the outside. So this is where the thrust comes from, this fan, and this turbine here, the power turbine, is just big enough to drive the compressor and the fan at front. And so you get about 20% thrust out here, 80% thrust out here. And notice that the way they're keeping the noise down on these new turbofan jet engines is that they're putting these chevrons that are shaped like this on the outside, which reduces the noise. And so this is a turbo fan jet engine, and you can see that the fan is at the front there. So the answer there is A. 18. Which of the following electronic components is a semiconductor? You should know that it's a transistor. None of these are semiconductors. Which is the common copper alloy used universally in electrical and telecommunications applications? ETP is the one that is universally used, electrolytic tough-pitch copper, which is almost 100% pure copper. You don't want it to be an alloy because it inhibits it, it creates more resistance, but you have to have a slight bit of alloying to increase the strength of it, but not much. It's I think it's about 99% pure copper. Question 20, the microstructure of carbon steel is shown, which best describes this steel. When you have a look at these, you can see that the grains are elongated, so straight away they're being worked hard. And secondly, you have a look at the dark areas, and that's pearlite, and the white area is ferrite, and you can see that there's a massive amount of ferrite there. So it's either 0.1% carbon anneal, it's definitely not 0.4. It could be 0.2, but the cold roll still gives it away for D. So it is 0.1% carbon cold roll steel. Okay, so let's have a look at section 2, and I'll go through these now. Improvements in materials over the last 150 years have made a significant impact on civil structures with reference to the stiffness of the structures, the height of the structures, the durability of the structures. Outline how the improvements to materials have affected any two of these features. Now, when I marked this, a lot of students repeated the question and the answer. It's a waste of time. All you have to do is, with outline, you've got to sketch in general terms and indicate the main features. So you don't put that into a sentence, you just say stiffness, right? Or you can put stiffness of the structures, but I just put stiffness there. And then you outline the main features here. So materials that have been developed with a higher Ms modulus results in less necessity for bracing, less material quantity and volume, and easier assembly of the components. Okay, so you've outlined that first one. Many students just gave me a whole lot of pros, and you couldn't pick out where the stiffness was, where the height was. But this method of presenting your answers is by far the best. Saves time, and it's easy to mark, and it is succinct and straight to the point. So high strength modern materials have facilitated increased height of structures. And durability, anti-corrosive fire materials, as well as more durable concrete, have extended the life of civil structures. 21B, discuss how society has been impacted by any two of these features. Again, don't say society has been positively impacted by the stiffness of, we don't want to know that. We just want to see how stiffness has impacted society. And so you just do it succinctly. Stiffer, stronger materials reduce the cost of material, quantity, and handling, resulting in less cost to the consumer. Height allows for greater housing density and durability, longer life. Now, this is the best way of presenting these sorts of answers. Don't be verbose. It's a waste of time and you're not getting any marks for it. Students think that if they repeat the question here, it sounds more professional. It may in English and history, but not in engineering. Next question, 21C. Aeronautical engineers always aim to reduce parasitic drag and induce drag forces in aircraft design. Contrast. Now, contrast means to show how things are different or opposite. And so you, once again, just put parasitic drag. I had one student say, drag on an airplane reduces the fuel consumption and he didn't get straight to the point. This way you get straight to the point. Parasitic drag, now, is the drag resulting from any shape moving through a fluid. So that is, you throw a rock, that's parasitic drag. But you put wings on the rock, that's induced drag. Induced drag is the drag resulting from the addition of elements. For example, the wing, or the winglets, or the ailerons, or the rudder. That's what produces induced drag to allow the plane to fly. But the parasitic drag is just an object, the drag associated with an object going through a fluid. Outline how the reduction of aerodynamic drag on aircraft benefits society. Most people got that right. Drag reduces the efficiency, which results in extra cost to the consumer, more noise to passengers, and less range, thus requiring more stopovers. I don't know whether you've experienced when you've been landing in a fairly big plane, when they want to slow the plane and reduce altitude, you see these spoilers come up in the center of the wing, and you get massive vibration coming through the plane. And that's because you've spoiled the airflow, and you've created turbulence behind that, and it causes massive buffeting because there's a lot of force on that wing. Just imagine what an A380 goes through when those spoilers come up. Okay, this question here wasn't very well done. Calculate the magnitude and direction of the reactions that supports A and B. Look, the first thing you do with a question like this is put all of the forces on there, because you're going to get one mark. Like here, provides one correct response. You get one mark there. So if you show the examiner that you know that you've got 3 kilonewtons acting through the center of mass, you put it on the center of mass because you've got 2 there and 2 there, you'll get 1 mark for that. And look at all the forces, they're all vertical. Even though you've got a pin here, there's only a vertical force there. Because these other forces are all vertical. There's no horizontal component to those forces. And so these questions are relatively easy when you put all of the forces on. And I would even show the examiner that you know that that's 90 degrees by putting a little 90-degree bracket there, and a little bracket there. You'll definitely get 1 mark. So the first thing you do, after you've put all the forces on, the first thing you do is read the question twice. And then the next thing you do is put all the forces on. And then you 95% of the time you take moments about the pin. So I've taken moments about the pin here, and you get a positive answer here, and that indicates that that sense is correct. It's going up. Okay, so if you've got a positive answer here, because I've said that RB times 2.5 is negative, so that goes anti-clockwise, and I'm just guessing at that. But this answer here, because it's positive, shows that it's correct. The other thing that foiled a couple of students is this. When they give you 60 degrees here, you take all these, it's an equilateral triangle, and you take all these member lengths as 1. or 10 or 20, but I just take it as 1. It's much easier. And so the perpendicular distance of this force about that point there is 1/2 plus 1 plus 2, and that's 2.5 there. And so you're telling the examiner that that's going up again here, but you've told them it's going up there. And then you've told the examiner that you don't have to take moments again. You know that all the forces are vertical. And so you just say some of the vertical forces, and you're saying that this force here is going down. So you've got minus RA there. You get a positive answer there. And so it tells you that it definitely goes down. And so that's a relatively easy question. You should be able to do those things. These are a little bit more difficult, as you can see with the marks, 6 marks, 2 marks for each force. So the theory behind this is that you cut the truss, you neglect the complex side, and this remainder of the truss has to stay in space with these 3 forces holding it up. So everything's in equilibrium. So if you took moments about this point here, some of the moments about this point is equal to 0 because it's in equilibrium, but it's silly to take moments about that point because you'll end up with 3 unknowns in the equation. So you've got to look around and see where you're going to take moments about to eliminate the other 2 unknowns, because you're only allowed to section 3 members. But before we do that, let's just find this inclined force. Now, because all these forces are vertical and you've got a horizontal top chord and a horizontal bottom chord there, you can break this up into vertical and horizontal components. And because we're only taking the left-hand side, y sine 60, the vertical component in that inclined force there. Now, don't forget, I always put tension. These members are in tension. See, I've put a question mark there. So the vertical component of that force there, because it's in tension, is going up. And that force there has to equal that force there. And so, so the sum of the vertical forces equals 0 with up positive. So you've got minus 3.4, that force going down. Plus you've got the component, the vertical component of that cut member going up. That equals 0. So, and you've got a positive answer there. So tension is correct. Notice I put question marks there because I'm telling the examiner that I'm just guessing. So I've even written it down here. Assume cut members are in tension and eliminate the right-hand side. So we have to find the force in X and Z now. And to do that, you take moments about a point that's going to eliminate one of those forces. So I'm going to take moments about D here, because the force going through Y goes through that point. So the moment of that force about that point, 0. The moment of that force about that point is 0 also. So I'm going to say, and I'll tell the examiner where I'm taking moments about. So I've got some of the moments about D equals 0 with clockwise positive. And so you've got to work out what this perpendicular distance is. If it's 60 degrees and you're taking all members as 1 in length, that's 0.866. And so I've got X times 0.866, and that's going to go clockwise, minus 3.4 times 1, which is going anti-clockwise. And so you get an answer 3.9 kilonewtons. And because it's positive, it's in tension. Now I've got to find Z. And so I'm going to take moments about D here, C there. And course, that'll eliminate the moment of that force and the moment of that force there. And you're allowed to take moments anywhere. Don't forget, even though this is gone, you can take moments about anywhere. Remember, I said you can take moments about here because this part that's left here is still in equilibrium. So some of the moments about C equals 0. So we've got Z going anti-clockwise, so it's negative, multiplied by the perpendicular distance, which is 0.866, minus 3.4 times 1.5, because that's going anti-clockwise. And see, when you've got two anti-clockwise there, you're going to get a negative, and that tells you that Z is not in tension, it's in compression. 6 marks for that, and it's worthwhile studying that. For another loading, this is E. For another loading, the force in the metal bar that is supported at B is 150 kilonewtons. If the round bar material has a tensile strength of 600 megapascals, determine the minimum diameter of the bar. Read it twice, put the appropriate formula down, put all the data down, and then just substitute it in the equation. Make sure that you multiply millimeters squared by 10 to the minus 6 to bring it to meters squared, and you'll get the radius. If you use R there, you'll get the radius. Make sure you multiply it by 2. You can use pi d squared on 4 here, and you'll get diameter straight away. And it works out to be 17.8 millimeters diameter of the bar. This one gave students a lot of grief, and I'll just go through it slowly. Remember, to get the velocity ratio, you can use diameter or you can use the number of teeth. You can use radius as well. And so to get the velocity ratio of this gear assembly, you do it in reverse so that you can see that this little gear will go much faster than, this is the driver gear, and this is the driven gear, we'll say. And so this will be going much faster than this gear. So you've got to use the reciprocal. So let's have a look at this here. The velocity ratio of this gear assembly, let's say that's the driver, and this is the follower or the driven. The velocity ratio of this, if you took that at 40 divided by 112, it's going to tell you that that's going to go slower than that. But you know that that one has got to go faster than that. So you do the reciprocal. So the velocity ratio of this gear here set up is 112 over 40. Now, if you've got a gear assembly, you multiply the velocity ratios of the other gears. So the velocity ratio, if the velocity ratio of the gear train is 5.6, determine the diameter of gear B. And this is gear B here. So the velocity ratio is 5.6. So this is how you work back. So it's 112. We're working back from the driven gear. 112 divided by 40. So we've got 112 divided by 40. Then you multiply the next gear train. And so this is X, or teeth, diameter, divided by 40 there. And so you just work that out and you get the gear diameter is 80. Okay, so that's how you work out these gears. Calculate the mechanical advantage of the gear train if the efficiency of the system is 40%. Remember, the velocity ratio equals mechanical advantage at 100%. So the mechanical advantage of this gear train is 5.6. That's not taking into account friction. But because this is 40%, you multiply the velocity ratio by the percent. You don't use percentage, you've got to use a decimal. So 40%, you divide that by 100, and that's 0.4. So that's 0.4 times 5.6, and that gives you the mechanical advantage of 2.24. If the driving gear is gear A, so let's have a look at gear A. Here's gear A here. The driving gear is gear A and it revolves at 1500 revs per minute. Calculate the speed of the driven gear D. Have a look at D. D is right at the end. That's this one here. Assuming an efficiency of 40% for the gear train. So the velocity ratio doesn't vary with efficiency. It's only the mechanical advantage. So that was put in as a bit of a furphy. And you've got to know that mechanical advantage varies with efficiency, whereas velocity ratio doesn't. Just apply it to your bike. Your pedals will go as fast as the wheel always, but even though you've got a rusty chain and it's absorbing a lot of energy. So the velocity ratio is 5.6. Therefore, the gear D revolves at 1500 divided by 5.6, and so that's to 67.9 revs per minute. So you can see that gear A is going much faster because it goes 5.6 times faster than gear D. If the input torque, now remember torque is a moment, it's Newton meters, at gear A is 50 Newton meters, calculate the output torque at gear D, assuming an efficiency of 40%. Now, the torque will vary according to the efficiency, mechanical advantage, because of the absorption of energy as a result of rust or lack of lubrication. So the mechanical advantage is equal to load or output torque over effort or input torque. And that equals 2.24 because we're taking efficiency into account. And so you can work out that the output torque at D is 112 Newton meters. Okay. And that's because of the gear train providing an increase in torque. Each gear requires heat treatment to produce the two mechanical properties of a tough core and a wear-resistant teeth. If the gears are made from 0.5% carbon steel, name and describe a suitable heat treatment process that will produce the two required mechanical properties. And you just described flame or induction hardening because it is 0.5%. It's above 0.3%. If it's below 0.3%, you'd have to put carbon into the case and you use carburizing. This question was really poorly done, and I'll just go through it fairly quickly. You have to develop these two faces, that face and that face. And the way you do it is that you've got to put true length lines on each of these developments. And I've got a YouTube video that explains how to do this more thoroughly than I'm going to do it now. So the rule is that if you want to find the true length of AB, you look in the other view, and if it's horizontal or a point, this is a true length. And so you look down here, there's AB, so that's horizontal in the other view, so therefore that's a true length. Now, if you want to see BC, is BC a true length here? You look in the other view, it's not a point, nor is it horizontal, so therefore BC up here is not a true length. Let's have a look here. Is BC a true length down here? You look in the other view, you see it's not a point, nor is it horizontal, so BC is not a true length there. So when you have decided that the line is not a true length, you have to use these height lines, and this is what the markers are looking for, that you've used these height lines. So if you put your compass on BC, you're getting the base length of the imaginary triangle. So here's BC here. You put your compass on that in top view, and you're getting that length of the triangle. And so you put your compass on there, get that length of the triangle. You see how high B is above C. So you use this height line here. And so there is the base length of the triangle. So that's a true length of the base. That's a true length of the height. So the hypotenuse must be a true length. And that's what you use for the development, because all of these lines have to be a true length. And that was worth 6 marks, so it's worthwhile practicing this. Sheet metal, the sheet metal transition piece, the above is galvanized. Explain the purpose and process of galvanizing. Now, this question is asked, and they've asked you to explain. And so that means it's not just a statement, it's an explanation where you have to make sure that you give relationships, cause and effect, and provide how and why. So, and I like to set it out like this because this is worth 3 marks, and here are how the 3 marks are allocated. And so you're getting straight to the point. So you explain the purpose of galvanizing to protect the underlying steel from corrosion by applying a layer of zinc, which is higher than the base metal on the electrochemical series, so that will have become a sacrificial anode. And then the process, you've got to explain the process. Now, because it is sheet metal, you don't hot dip it because it will bend it and distort it. You apply the zinc by electrolytic galvanizing, which is explained in the book. So make sure that you study this and answer like this. This is the best way. The 1 millimeter thick galvanized sheet steel is to be joined using 5-5 rivets. If the strength of the sheet metal is 200 megapascals, determine the force required to punch each rivet hole. Now, the first thing that we look for when we're marking this is what area you use. And the area has to be the circumference of the rivet multiplied by the thickness of the plate that you're punching it through. So we're looking here. So the circumference is pi d. So there's pi d there. The area of shear is pi d multiplied by 1, which is the thickness, and you multiply it by 10 to the minus 6 to bring the meters squared. So you put your formula, you put your data here, and you work out what the force is. Question 25A. These questions, if you do them the correct way, they're quite easy. So this fellow is holding, he's required to initiate movement up the plane. So if movement goes up, friction goes down. It opposes the tendency of movement. And so we want to get 3 forces on this. So we can use the 3-force rule. And the 3-force rule says if a body's in equilibrium and 3 forces are acting on a body, the 3 forces will all pass through the same point. So we've got the weight force acting down here. You put your pushing force there. You put your normal there. And you've got friction acting down here. Now, that's no good because we've got 4 forces. So we're going to add friction and the normal together, and you get this angle of static friction. You get the resultant of those two. And so you've got to work out what the angle is between the normal and the resultant. And you do that by tan phi s equals mu, which is 0.2. So phi s is equal to 11.3. And I'd advise you to do this graphically because you're getting 10% leeway. You use your protractor, you use their diagram, and then you put your resultant in, and that will eliminate the force of friction and the normal. So you've got 1, 2, 3 forces acting there. I use Bose notation. A goes around to the resultant, B goes from the resultant to the pushing force, and C goes from the pushing force around to the vertical force. And then you just do your force diagram, and you can work out what the pushing force is. You make sure you show the examiner that you're using a scale here, and you just measure that, apply it to the scale, and you get the answer. Worthwhile learning that because it's quite easy once you get the hang of it. Identify the functions of the following components commonly used in modern electronic circuits. Now, there's no excuse. A person is diligent studying this will study these. And so transistors, no verbose explanation, just put transistors dash. They're semiconductors, and they perform two functions. It's amplification and switching. And printed circuits now and chips have billions of transistors, and they're getting down to almost atomic level. Now they're getting so small. Zener diode is virtually no one got that right in my class. They use as voltage regulators, and they can pass a current through in both directions, which diodes can't. LEDs are diodes that emit light as a result of the electrons jumping from orbital to orbital to emit photons of light. And so therefore they don't lose energy in the form of heat, but the electronics do heat up a little bit, but the actual emission of light produces no heat. And they're very efficient. Laser diodes, these are diodes. A laser is a frequency, a single frequency of light. So these diodes emit light at one single frequency. Hydraulics, calculate the velocity ratio of the hydraulic system. Look, this is always an easy question. If you remember this, you don't have to derive it. It's not in your formula sheet either. So the velocity ratio of a hydraulic system is big phi squared, the big diameter squared, divided by the little diameter squared. And remember that big phi is the big bubble and it floats on top. So it's big phi squared over little phi squared, and it's an easy question. So you've got a velocity ratio of 7.1. Calculate the pressure in the hydraulic fluid if the input force is 500. Now, pressure is the same as stress. That's force divided by area. So you've got 500 there. The area is pi r squared, and it will be 2.8 megapascals. And make sure that you know how to do a section drawing. Make sure that the section lines actually go through the thread if there's no bolt in the structure. But look at down here, these section lines don't go through this bolt here, but they go through the thread there because there's no bolt there. And you're allowed to show only two faces here because the other view shows that it's a hexagon. And this is how you do an external thread. This is how you show what part is removed. Now, make sure that all views are projected in the line. Don't put this view up here because it's got to be projected from this view. And you'll lose a lot of marks for that. When you show a section, make sure the end of the arrow is thick dark there. The 10mm thick plate used on the machine part is being cold rolled. In the circle divider, make a local sketch of the grains after cold rolling. Make sure that you show that they're elongated, and make sure you label it. Question 27, part A. you have these logic gates and you're asked to find what logic gate is here and what logic gate is there to produce this output. And the way you do that is you weren't given any of these values here. You had to work out what those values were, because it says here, by completing the truth table. If you just put down this logic gate is an and that's an or, you won't get your 6 marks because you're asked to complete the truth table. And so if you've got an input at A, but no input at B, and you get no input out there, this could be an and, but it's definitely not an or. But if you have no input at B, no input at C here, like this, this could be an and with a 0 output at E. This could be an and or an or. So you come down to the next one, and this seals it so that you've got the 0 input at A, 1 input at B, and so this coordinates with that. So that's got to be an and. But let's have a look at this here. So you've got a output at E there, and you've got an input at B, so that's got to be an or. So that's an and that's an or. Okay, this question, I'll just show you this question. That was the question for the logic gate. And this is the question here. You're asked to do the signal wave, then you're asked to do the carrier wave, and for both of these situations. So let's have a look. So modulated digital and analog waves are shown. So you've got a digital wave here, and you've got an analog wave up here. Sketch on the axis provided the 2 waves, wave 1 and wave 2, that are components of the 2 modulated waves. So you had to show the signal wave, you had to draw the signal wave, and you draw the carrier wave. And the carrier wave was modulated with FM, frequency modulation. And so you had to put where it's negative there, you had to put low frequency, where it's positive there, you had to put high frequency. Same thing here, where you have digital wave, where it's on, which is the 1, it had to be modulated with a higher frequency, and where it's off, it's a lower frequency. And so that's frequency shift keying. And if you haven't drawn those before, then you've got to make sure that you can draw them. Okay, that's it. I hope you go well in the HSC. Bye.